we need to talk about a couple things, actually. Things that are increasing, that are unbounded, that are limitless. Well, maybe not limitless. You know what I'm talking about, don't you? I'm talking about logarithms and exponential equations. Today we take derivatives of logarithms and exponential equations. You know, it's kind of funny. We start out with calculus, we do the difference quotient, and for a lot of students that's pretty difficult, and then suddenly, boom, there's a power rule. Slide and subtract that thing down and off you go, and that's pretty easy. Well, the trend is going to continue today. There's going to be some challenges within logs and exponentials, but the rules are pretty simple. Let's start with the logarithm. Okay, here it is. If you want to take the derivative of some natural log that has some function on the inside of it, all you do is you take that stuff in there, I'm going to call it the guts, and you rewrite that on the bottom of a fraction. You take the derivative of those guts, and you write that in the numerator. And that's all it is. Okay, let's look at some examples and get really good at it. Okay, here's the first one. Natural log of x. When we see a natural log, instantly, we know there's a fraction. We take this stuff, and we write it on the bottom. I'm calling it stuff, but it's some expression or some function that's sitting in there in x. Write it down there, derivative of x is 1, that's what goes in the numerator, so boom, there you go. Let's do another one. Let's do the derivative with respect to x of the natural log of 12x. Okay, natural log, boom, it's a fraction, write exactly what you see, 12x, write the derivative of that up top, that's 12, the 12's cancel out, and so we get 1 over x. Now, isn't that a little bit weird? We've got 1 over x is the derivative of natural log of x. The same exact derivative is also associated with a different function. What the heck is going on? I mean, what if that was 120, for example? 120, then this would have been 120, and that would have been 120, and they still would have canceled. So what's going on? Here's the deal. If you have a derivative of a natural log of some constant k multiplied by x, what is that k really doing? Is it a shift, a flip, a rotation, or something different? Some sort of transformation. Remember back with logarithms, if you have quantities that are multiplied together in a log, you can stretch that out to addition. So that is natural log of k plus natural log of x. And here's where it gets kind of fun. Natural log of x, we already showed, is 1 over x. What about natural log of k? Well, natural log of a number is just a number. And the derivative of any number is just 1. So that's why we get the same derivative. Let's look at a few more examples and get a little more comfortable. Here's our second example. Okay, it's a fraction. You write what you see in the denominator. Derivative of x is 1. What about the derivative of e? That's a number, so be careful. It's just a number. So you take the derivative of it, it's 0. So there's your derivative. That's done. Okay, a couple more. Okay, what about this one? Fraction, write the guts in the denominator. 9x to the 8th minus pi x squared, pi plus x. Derivative on top. Bring the 8 down, subtract 1, so you get 72x to the 6th. Bring the 2 down, subtract 1, plus, or excuse me, minus, sorry about that, minus 2 pi x, derivative of x is 1, so plus 1. It's done. We don't even need to simplify it. Well, here there's really not much we can do, but that's all done. We've demonstrated an understanding of calculus. Now, what about the exponential function? It's pretty similar, pretty simple. Here it is. Okay, you can write it down, but here's what it means. It says if you need the derivative of e to something, I don't know what it is, it could be e to anything, what you're going to do is you're going to write down what that something is. Okay, there it is. Write it down, and then you're going to take the derivative of whatever's up there, and you're going to write it in front. Okay, that's all it is. Let's look at some examples. Okay, so this is a weird case. E is its own derivative. If this is what we got, remember, you take what you see and you write it, and you write the derivative of the exponent. Derivative of x is 1. 1 e to the x is just e to the x, so we don't have to write that. And so that's another example where e pops up in a weird way in math where it now is its own derivative. It's one of the only functions that has that property. There it is. Okay, what about this one? Okay, you can do all kinds of rules if you want, but be careful. What is e to the 7th? Is that an equation, an expression, a number, a variable? What is that? There's no variable at all, which means it's a constant. Derivative of a constant is 0. Done. One final note before we close. Sometimes people get confused when they see e to the x and they're taking a derivative of it, and they think, you know, I think that I could probably just slide that down there and subtract 1 from the exponent, and then the answer to this would be x e to the x minus 1. And so something I want you to think about is, why is it that we can't do that? Why do we need a different rule for exponentials? Why couldn't we just apply the power rule? Okay, and you got to think back to where the power rule comes from. The power rule only applies when you have x raised to some power. The e rule, power rule, e rule, the e rule only applies when you have e to some exponent that has x's within it. So I hope you see the difference. In the power rule, that applies when the base is something with an x in it. And the e rule applies when the base is e, but the exponent has x's. So be careful. You got to be really careful and make sure you use the right rule at the right time, or you can get into a little bit of trouble. Going back up to this example, or even our previous examples, we can see that here the base is e, the exponent is stuff that has x's in it, and since the base is e, we need to use the exponential rule. That's all for today. I hope this helps you understand the exponential and logarithmic derivative rules a little bit better, and until next time, have fun!